now it works. Hello, everyone. Welcome to Data and AI Summit by Databricks. I'm Jerry from Databricks. The topic of this section is CDC with DLT and AWS DMS. Now, please join me to welcome our speaker, Neil Patel and Ganesh.
Good afternoon, everyone. I'm delighted to see all of you here. Now, I must admit, in a world where chatbots are writing essays, AI is composing music, and large language models such as ChatGPT is threatening to take our jobs away, you still made time to come to this talk and hear us talk about the boring part of AI, which is data engineering, right? But we really hope that by the end of this talk, you will walk away with the recipe to build reliable data pipelines that is continuously processing change data feed from your database and really unlock many data-driven use cases in your organizations. So let's get started. But first, quick introduction. My name is Ganesh. I'm a lead specialist solution architect at Databricks. I've been here at Databricks since 2016. Co-presenting with me, I have my coworker and my teammate, Neil.
Hi, I'm Neil Patel. Just like Ganesh, I'm the lead SSA at Databricks. Been here for about 4 years. And this talk is basically was based off a second part on a blog, a 3-part blog series. And hope you enjoy the talk today.
Right. Go back.
Okay. I think a slide might be missing here, unfortunately. We would be having the initial 4 talk points that we're going to go over today, which is what is change data capture, AWS DMS specifically, and third, DLT, Databricks Delta Live Tables, and fourth, bringing it all together in a demo. And our first topic is going to be why CDC.
Right. So why do we care about CDC, right? So we understand that CDC is the process of identifying and capturing changes happening in your source system tables, and then processing them and applying those changes in your downstream systems, right? But if you think about it, almost all transaction systems are backed by relational databases. And CDC really allows you to update changes from these databases and unlock many data-driven use cases that will benefit your organizations. And we will take a look at some of them. The first one is data replication for BI and AI. What this means is that CDC enables us to keep our data warehousing and data lake fresh and up to date and in sync with our source system tables. So what does fresh data warehouse gives us? It means that you can build operational dashboards and reports. So you can take actions immediately as events happen in your application. What does fresh data lake gives you? Well, your ML models and AI applications can benefit from real-time data to improve the accuracy of predictions and adapt to changing conditions. And because we can have a historical evolution of our data, these historical changes can be valuable for AI models to understand the trends, patterns, and relationship over time. Next, we will take a look at the data integration. So in multi-system environments, right, maintaining data synchronization across these systems is really challenging. So CDC really simplifies this by immediately reflecting changes made in one system and propagating those changes to other systems. And it also dramatically reduces the amount of data that you need to transfer from one system to another system, because you are processing changes as they're happening and not doing the traditional batch way where every night you would take a complete dump of the table, right? Next up is event-driven architecture. CDC really can play a significant role in event-driven architecture where a state change of one service can trigger events that other services can react to or respond to. And finally, many industries have regulatory requirements to retain historical data for a certain period or to report data changes. So with SCD type 2, or slowly changing dimension type 2, businesses can not only ensure they have the necessary data to comply with these regulatory requirements, but also have a proof during security audits as the SCD type to provide a very transparent view of data changes over time, right? So now we've understood what change data capture is and why is it important to you. Now Neil will talk to us about how historically we've been doing change data capture and what's the modern way of doing it.
So I think our slides got mixed up a little bit, but just one thing to clarify here is what is change data capture. Capturing changes from a set of data sources. So for us, in this sense, would be a relational database. And basically, the goal is to get the data in a format that we can figure out what was inserted, updated, and deleted. So in this case, we can see this person was inserted, a new employee, and then he got a raise, and then he promptly used that raise to leave the company. And then going forward, we got a new employee that was added, and then the third employee was added a little bit later. And this kind of tells us the history of that whole employee table. Hands up here. Who has leveraged Hadoop and Scoop to bring in data in the past? Okay, I see a few hands here. So how is that usually done? It's generally done with JDBC. And that comes with like a myriad of problems. Primarily is that one of the big problems is that you're most likely reaching into some production database, and that's generally frowned upon. Secondly is you need to keep track of what was last read. You need to keep track of the primary key or maybe last modified timestamp. And then next run, you need to basically go greater than that. But also, if your table, let's say, has hard deletes, you also then need to come up with some logic to via full outer join to some degree and case statements to figure out what was updated and deleted. And the second scenario that we often see is snapshots. Some upstream team will maybe do daily snapshots of some database/tables. And then from there, you will need to basically get that file. They drop it to you in some CSV or Parquet. And then from there, again, same thing happens. You need to do a full outer join to some degree to figure out what was changed and updated and deleted. But also, reading a daily snapshot is quite expensive too. So it's a paradigm that, if you're cost conscious, you want to avoid. But one thing, at least at Databricks with Delta Live Tables, we have seen that as a common use case, and we do provide a way to handle that, and we'll talk about that later on in the talk. And so how do we do CDC the right way? Generally, it's with a transaction log. And so what is a transaction log? It basically contains a myriad of information that happened on the database, not only data that was changed, but also SQL statements. For us, that includes the CDC data, that's what we care about, who ran a query, and additional auditing level information. And specifically for this talk, on the MySQL side, it's called the binary log. But if you're using other systems that DMS supports, Postgres, it's called the write-ahead log, and so forth. And for us, our goal is to parse the transaction log and give us the relevant data of what was updated, inserted, and deleted. And this is why CDC tools are a growing industry and a growing kind of business model, because all these databases have a standard format which they write out that information. And so kind of want to go over a few of the CDC tools, specifically first starting off with the easiest to kind of integrate with first being the cloud vendors one. So for us, we're doing AWS DMS, but if you're on Azure, they have Azure Data Factory, which now supports directly writing into a Delta table. And there's also GCP data streams as well. And then second, you have the SaaS vendors. From there, you have Fivetran, Archeon, Informatica. And third, you have the open source, arguably the highest TCO in terms of people hours and just infrastructure needed for that. And the most common and popular tool for that would be Debezium. And so for this talk, we'll be focusing on using AWS Database Migration Services, also commonly known as DMS. And so just reiterating, what is a CDC tool? It's basically the transaction log contains a variety of information. Our goal is to parse and filter it and ultimately give us this output, just with insert, update, and deleted, and the timestamps associated with that. And so what does DMS need, as a CDC tool need to work? First, the respective database needs to have the transaction log enabled, and AWS has a great write-up on what database system you're using and then how to enable it. For our scenario, we're using MySQL as our source. So you need the two main configs you need to have would be bin log format equal to row, and the bin log row image equal to full. And then subsequently, if your source is not a MySQL primary database, but rather a slave, you also need to set up log slave updates equal to true. And this is just a high-level picture of kind of what happens in terms of the interplay between the bin log, AWS DMS, and Amazon S3. So it's RDS and MySQL is writing out the bin log, and then AWS is reaching in and grabbing out, reading the bin log, parsing it, and then writing it out to S3. And secondly is we have our target endpoint. For us, it's S3, and there's a myriad of options here that are relevant for us. First being the data format, CSV or Parquet. Parquet is a really good format to use, especially with Databricks Delta Live Tables and Autoloader, because we provide an auto schema inference. So if you have a lot of tables you're writing out and you don't know the schema, or it's just too much to keep track of, we can automatically infer the schema for Parquet files with Autoloader on Databricks. And then secondly is if you want to have larger files, if you have a lot of activity on your transactional database, there's two configs here, would be CDC max batch interval and CDC min file size. You would kind of decrease the batch interval size if you wanted to get the data as near real time as possible into S3, or if you maybe wanted to have larger file size and more efficiency, you could increase that time in combination with the CDC min file size. And thirdly, you have the timestamp column name. That basically means that DMS will add a timestamp column onto the files as they're being written out. And this is important, more so important when you have, let's say, hard deletes on your database and you're not keeping track of it in the sense of like with a is deleted flag or something. And so what it does is, and one thing to note with CDC, it's going forward, right? So if you were to start a replication with AWS DMS on a database, it does initial snapshotting to S3 of the current state of the table, and then CDC is ongoing. And the timestamp that is being written out for the initial full load is basically when the file is written to S3, and then the CDC data is basically based off the commit onto the database system. And then you also have add column name. If you're using CSV, you can provide the header onto the files. And then the last one is use task start time for full load timestamp. Whereas if you, for some reason, see on your data that the timestamp from DMS between the full load and the CDC data has overlap, you might want to look to considering enabling this flag, because then the timestamp that's put onto this files on the initial load is basically the start of the task time, not when it was written out. And this is more important on how it handles open transactions, DMS. And they have a great write-up on this, and we'll have it in the deck of how DMS handles open transactions and when it decides to start doing replication. And then just to kind of round it all off, just an example of what a bin log looks like for MySQL. As you can see here, it just has a lot of information in there, and our goal output is this of input updates and deletes. So this is why kind of nobody really rolls your own anymore. It's some level of using a combination of SaaS vendors, native services, or an open source tooling. And let me hand it over to Ganesh to talk about Databricks Delta Live Tables.
Awesome, thanks, Neil. So quick show of hands, how many have you been using Delta Live Tables already? Awesome. Oh my God, almost like 60%. And remaining, have you ever, like, you've never used Delta Live Tables at all? Okay. The good news is that, you know, Delta Live Table is supposed to have a very low entry to, low barrier to entry, right? If you're using Databricks as your lakehouse platform, sooner or later you will use DLT, and you'll see how easy it is to get started. So we're not assuming any prerequisite of DLT knowledge in this talk. So you're welcome here. Awesome. So let's talk about DLT. So DLT is a declarative ETL framework built on top of Apache Spark for building reliable and testable batch and streaming data pipeline that deliver really high quality data on the Databricks Lakehouse platform. So what does declarative framework mean to you, right? It really means, instead of like focusing on how to accomplish a task, step by step, you really describe the outcome that you want, the output that you want, right, from a data set. And DLT takes care of the orchestration, task dependencies, and all the, underlying infrastructure level. So you as data engineers, data scientists, data analysts can focus on solving the data problem, and DLT takes care of the rest of the underlying problems, right? So DLT fully supports Python and SQL and is tailored to work both batch and streaming workloads seamlessly. Let's look at the key benefits of DLT. So I'll be really quick here. It enables data engineering team to accelerate ETL development by providing declarative APIs in both Python and SQL. And it's super easier to use. It abstracts away the complexities of stream processing. You no longer have to reason about the output mode, checkpoint directories, what kind of trigger mode that you need to use, right? And it manages the infrastructure for you. It can auto-scale, depending on the spike of the input data volume. And DLT pipeline has the ability to self-heal, from cloud transient errors, right? With automated error handling and restart of that specific flows within your pipeline. It also automatically detects the regression during the upgrade, and it will point to a specific Databricks runtime version, or DLT has its own runtime version if it detects there is a regression. Because one of the main pain points if you've been a Databricks customer is that every time you try to upgrade to a new DBR version, you always sometimes you do see regression, right? And that's why you choose to stay behind, way behind than what's the current LTS version. So DLT solves all of that for you. You no longer have to reason about the runtime version, Apache Spark version. So all of that complexity is taken care. Next, delivering high quality data is the most critical task for us data engineers, right? And DLT helps you achieve this goal by providing you pre-built tunable error handling policies. You can choose to drop the bad data. You can choose to quarantine the bad data so that you can inspect them later and then reprocess them. And it also allows you to track and monitor data quality in real time. It comes with the event log where all the DLT events are being captured. And then it also provides many other things, lineage, data set documentation, expectations, etc. And finally, we all know Apache Spark, right, was one of the first distributed engine that really unified the batch and streaming by providing a single unified API, data set or data frame. But DLT takes it even one step further by abstracting away all of the complexities that I mentioned before, like having to reason about the streaming state and checkpoint directories, the cluster provisioning, and all of that. Whether it's batch or stream, you can basically compose them in the same DLT pipeline, and you don't even have to know anything about streaming. So DLT has tons of other features. I can spend another hours talking about them. I work with many of our customers focusing on DLT, but this is not the DLT talk, unfortunately. We're going to focus on the CDC aspect of DLT. If you want to learn more about DLT, there are dedicated talks. The first one is Michael Laundra's talk tomorrow at 12:30 p.m., where he's going to talk about A to Z about DLT and the best practices when it comes to deploying DLT in productions. And DLT also offers you meta programming, which means that you don't have to write code every time you want to onboard new data set. You can actually use meta programming to automatically generate DLT code. And there is a lab project, Databricks Labs project called DLT Meta, and we have a talk that talks about how to go about how to develop configuration-driven way of developing DLT pipelines. And the talk is scheduled on Thursday, 3:30 p.m. By Ravi and Morgan from Databricks. Right, so now we'll look at the CDC Apply Changes API provided by Delta Live Table that you can use to process your change data feed and basically, whether you want to use SCD type 1 or type 2. Okay, so Delta Live Tables provides the first-class support for processing continuously arriving change data feed that basically represents insert, update, deletes happening in your source tables. It provides a declarative way where users pass the required parameters to the function, and you're good to go. You really don't have to worry about, how do I handle out of order events? What happens if partial updates come? So DLT automatically handles them out of the box. So let's look at the API. So this is the full signature of the API, but you don't need to use all of the parameters, right? Depending on your use case, you might use ignore null updates and apply as deletes and so on. But I'm just going to focus on the required parameters. So basically, you need to have a target table where you will be applying the CDC records, right? And you need to have a source that represents a CDC records of insert, update, delete events. You, of course, need to have a primary keys that uniquely identifies a row in your source data frame. And there needs to be a column by which DLT can sequence the events, right, in order to do out of order event processing. So I don't know about you, but I always love looking at the example to try to understand the API. So I do have an example here. So on the top right, you have a sample set of CDC records, right? The op column indicates whether it was an insert, update, or delete. And then we have standard employee ID, salary columns, right? That goes through changes. And then CDC timestamp is basically provided by your CDC tool that we can use for ordering of events. So the first step is to create a target table. Again, this API can accept other parameters like partition column and schema and so on, but those are all optional. The only required parameter is specify the name that you want to call your target table as, and that's it. And then you can immediately start using DLT.apply changes. Target is our employees table. Source is my employees raw that will contain those set of records. Employee ID is my primary key. In this case, I have a deletion case, so I'm saying op equals to D. And then I want to exclude op and CDC timestamp from being materializing into the target table, right? I don't need those tables downstreams. And here in this case, I'm just using SCD type 1, but you can just use type 2 as well. Here's the SQL variant of the same API. So again, here you have many clauses. Those are all optional. You just need to create a streaming table and then say apply changes into your target table from your source table, primary keys, and order by column. And here's a concrete example. Again, the same example written in SQL. So in the previous slide, I showed you the fragment code, right? That's only showing the CDC apply changes API. But I wanted to kind of like quickly show you what the end-to-end code looks like in DLT. So first we import DLT module that has all the functions. And if you've been a PySpark user, you know that's a standard PySpark functions import statement. Then what we have is we need to define source, right? In earlier, in previous slides, Neil talked about DMS providing CSV files representing change fields happening in MySQL database. So those are available in some S3 location. And so if you've been a Spark structured streaming user, you know what's going on there, right? So we're doing a read stream format cloud files. This is autoloader. And autoloader has inbuilt capabilities to infer schema automatically. And then we're returning a data frame here from this function. And then DLT then takes care of incrementalizing it for you. And it continues as new files, CSV files drop in that location, it'll automatically pick them and process them for us. So now that's our source table, right? Representing the CDC, continuously arriving CDC record. And on the apply changes side, we again create a streaming live table called customers. And then now we have a source. So we say source customer CDC records. Sorry, that should have been a raw. And then target is customers and key ID and so on, right? You saw that in the previous slide. And when you deploy this code as DLT pipeline, you'll see two data sets, right? The first one is the streaming table. That's a bronze table. And the next one is the silver table. So, and the first one is append only bronze table. We are just appending CDC events, and we're processing these CDC events, and then we're actually merging or applying them into the customer table. And customer table, if it's SCD type 2, it contains the history of your changes. All right, so probably now you all have been waiting for this, right? End-to-end demo, where we have a MySQL RDS, and then we have a DMS detecting the changes in the database, spitting out CSV files in S3, and then using Delta Live Table, we process them, and we have bronze and silver tables. So I would like Neil to cover the first DMS part.
All right, thanks, Ganesh. So let me go ahead and bring up our notebook here. So again, kind of a high level. If you happen to ever come across the blog, and again, in this talk, in the slide decks, we'll have a link, but in the blog, we kind of talk about how we did with Terraform, how we deployed this whole infrastructure, and how it goes about basically creating fake tables, modifying the tables, and so on. And this diagram kind of shows it all here. So let's take a look at some of the AWS artifacts we created here. So the first one is our AWS DMS. There's roughly like 3 parts to AWS DMS, right? Because AWS DMS is actually doing part like the actual reading the binary log and saving it to S3. So it has a replication instance, right? A node essentially, and then The other parts, if you remember earlier on, is we have our endpoints, or our source and target, which are basically called endpoints in DMS. And so, for instance, if we look at the MySQL, it's labeled as a source. And then in the endpoint settings, we kind of just have the very basic, for us, because we're using defaults for everything, so the bin log location, everything is already essentially known, because we're not changing the default location. And then if we go to, on the S3 side, again, same thing, our S3 is the target location, and we have the bucket folder. And then subsequently, we have the endpoint settings, some of the settings I talked about earlier. You can see here we have data format being CSV, and then further on, we have like our timestamp column name. That's called DMS timestamp, and so on and so forth. And like CDC max batch interval being 5 seconds. And then on the AWS RDS side, just kind of just showing that it's there. Okay. Yep, so we have the small RDS instance up and running, just a micro instance, and it has our kind of database called Databricks in there and the 4 tables. And finally, on the AWS side, just showing you some of the data that's already been there. So we have our database called Databricks. And the format of which, by default, DMS writes it out to S3 is basically the database and then the respective table names as prefixes. So this one, we have customers, products, stores, and transactions. And so if we go to products, for instance, we have a load file prefixed with LOD, basically implying that this file, or this is part of the initial snapshotting of the tables. And if we were to go to customers, for instance, we see multiple files in here. We see, again, the LOD file indicating the initial load. And then we have these various other files with timestamps, and these are associated with the CDC on that table. And then finally, we just show on the Databricks side, we'll show the initial run. And then this kind of just outlines what he talked about in terms of code, that we basically had our 4 initial ingestion pipelines, and then apply changes onto the target silver tables. And then let me go ahead and hand it over to Ganesh to kind of do some simple analysis on the tables, and then do the live demo.
Awesome. All right, so this pipeline is running in a continuous mode, right? What this means is that as the CSV files get dropped into the S3 bucket, it'll automatically process them. And we have set up DMS in such a way that if any changes that happens to the MySQL database, within 5 seconds, it gets replicated, right? So here's the notebook that this pipeline is actually running into, right? So I'm going to show you the quick analysis of the table.
Keep going, keep going, keep going. Keep going, one more. Yeah, there you go. Oh, you were just there. One more. Yeah.
Okay. All right. So our DLT pipeline, in DLT pipeline, you can specify which schema or the database that all tables need to publish to. I'm using that particular database. And when I run show tables command, right, you'll see 2 variants for each data set, right? One is customer CDC raw, representing CDC feed that we are persisting in a Delta table, and customers is where we are applying changes into. And so same thing for stores, transactions, and products. If you look at the bronze, right? So if you notice here, op. Now, if you look at the actual MySQL table, you will not have op DMS timestamp column, right? DMS is adding these columns, and it actually allows us to identify whether it's an insert case, update case, or delete case. And if you So if you scroll all the way to the right, there are some columns that autoloader is adding, like rescue data. If it's not able to parse records, it can those records will appear here. And then the reason we also added ingest file name here is because if you have a data corruption case, you can easily identify where the source of corruption is. So same thing for other raw tables. I'm just going to skip. Now if you look at the silver tables, right? So this is where we are applying changes into, and what you'll see here is if you sort it by the customer ID. Now notice the customer ID for 3, we have history, right? And then if you scroll all the way to the right, DLT provides 2 columns, start at and end at. End at null means this row is currently active, and if end at is null, that indicates at which sequence number value this row was expired. In this case, sequence by column is a timestamp, so we have a timestamp, but if you have a monotonically increasing ID number, you'll have that number. So let me go to the querying the latest data part. So when you use SCD type 2, every time there is an update, it's going to expire the existing row and it's going to create a new row, right? But then when you want to expose that table or view with DLT provides, every time you have to add this predicate and add this null, every time you care about retrieving only the latest rows. So especially for BI use case, what you want to do is you want to create this view which has this predicate already, and then expose this view instead, so they get only the latest rows. And let's do the live insert, update, deletes against MySQL database. So in this case, so we have insert, update, and delete cases here. So we created a utility, query runner, that is actually running this SQL statement that we are providing to this function against the MySQL database. So in here, I just wanted to confirm that this store ID exists, and right now the country value is US. I can change it to India and make sure and I'm inserting a new customer, let's say Ravi. Okay, we inserted that customer, and we can say Ravi, and we can delete some random transaction and make sure
that selects it.
Oh, sorry. Yeah, we're going to do it here. Okay, so that transaction doesn't exist, so we confirmed it by querying directly the MySQL RDS. So now, obviously, DLT pipeline has been running in continuous mode. We expect that by this time, these updates have been processed. So first, let's confirm. We added new customers called Ravi. So we got this customer, and we deleted transaction 80. So if we query from transaction silver table, what we expect is this row to exist, but if you scroll to the right, this row should have already been expired, right? Cool. And same thing for store. For the interest of time, I think this is the end of our demo. We will now take you back to the presentation, and we would like to give you a key takeaways. If you didn't, bother about the whole presentation, this last slide is all you should care about.